All right, so yesterday we talked about inscribed angles, intercepted arcs, what happens when a tangent meets a chord, right? Like all the different angle relationships that can be formed that way. So the first and probably biggest, most important thing you're going to use over and over again is that an inscribed angle is half the intercepted arc. Okay, we use that in a lot of different ways. So for number one, because that arc is 76, what's the measure of x? 38 degrees. Okay, 1/2 of the measure of that arc. And for number two, it's the reverse, right? They gave you the angle, so what's the measure of the arc? 56, and I get that by doubling the 28. Easy stuff, right? And yet kind of like the foundation for almost everything in this section. Number three says to find the value of x. So this one's 44, which intercepts this arc, right?
And they both intercept the same arc.
Good. Good. X also intercepts that same arc, so x would be 44. If you couldn't catch it, then you can double the 44, get that this is 88, and then cut it in half again, and you still get that it's 44. So hopefully the first way is easier because it's faster, but you can also get to it the second way. Okay, number 4 is a quadrilateral inscribed in a circle. And what do we know about the angles inside if it's a quadrilateral?
Opposite angles are equal to 180.
Good. Opposite or supplementary or add up to 180. So I can say that 2x plus 72 equals 180. 2x would equal 108. And x equals 54. And 4y plus 100 equals 180. 4y would equal 80. And y would equal 20. And I can plug those in to check if you want to, okay? All 4 of them should add up to 360. Opposites, again, should be 180. Questions on any of that? Okay, flip to your... All right, so 10.5 is called applying other angle relationships in circles. So we're going to do a little bit more with angles inside a circle, and then tomorrow we move on to segments inside a circle. These are kind of the angles that are, we kind of call them like floating angles or angles that are outside of the circle. So this is things in addition to central angles and inscribed angles. Theorem 1011 says if a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. We actually learned this yesterday, but now it's in a theorem format. That's the only difference. So when a chord hits a tangent, the arc that's intercepted would be twice the angle, and the angle would be 1/2 the arc. So in this diagram, the measure of angle 1, which is here, would be 1/2 the arc it intercepts, which is AB, and the measure of angle 2, which is here, would be the 1/2 the arc it intercepts, which is arc BCA.
Can you say the same thing as ACB?
Sure. And if you think about it, it should make sense because that's a line. A line would be 180 degrees. So if I did half of part of the circle and half of the other part of the circle, it ends up being half of 360, which is 180 degrees. So those kind of things overlap. Theorem 1012 is the angles inside a circle. So I call this like a floating angle. It's not in the middle and it's not on the circle. It's floating somewhere inside. And the way we find the measure is by adding the arc it intercepts to the arc its vertical angle intercepts, and then dividing it by 2 or multiplying by 1/2. So if I'm trying to find angle 1, which is here, then I add the arc it intercepts, which is CD, plus the arc that its vertical angle intercepts, which is AB, and divide by 2 or multiply by 1/2. So you're finding the average of those two arcs. If I want to find angle 2, then I add the arc it intercepts, which would be C, plus the arc that its vertical angle intercepts, which would be AD, and divide by 2 or multiply by 1/2. Okay, now we're dealing with angles outside the triangle, or the circle. So in Theorem 1013, which is angles outside the circle, the way we find it is they're going to intercept 2 arcs, or form 2 arcs. And we do the big arc minus the little arc divided by 2. So if I'm trying to find angle 1 here, I would do the big arc it intercepts, which is X, minus the little arc it intercepts, which is Y, divided by 2. if I want to find angle 1 here, the big arc it intercepts, which is x, minus the little arc it intercepts, divided by 2. And if I want to find angle 1 here, big arc it intercepts, which is x, minus the little arc it intercepts, which is y, divided by 2. So a lot of times I'll just say big minus little. Divided by 2, okay? That's how we're going to find an outside angle. So far we have 4 different types of angles. Angles on the center, which are central angles, those equal the arc. Angles that are inscribed or on the circle, which are half the arc. Angles that are floating, where we add its arc and the vertical angle arc divided by 2. And then angles that are outside, that we do big arc minus little arc divided by 2. So 4 different types of angles and 4 different ways to find them. Yep. So you want me to write them out?
Yes.
We've got the central angle, which would be 1 at the center, right? And its arc equals the angle. Then I've got inscribed angles, and that one has its point, a vertex on the circle, and the angle equals half the arc. Or that's also true for a tangent and a chord, because that point is still on the circle. That's true for both. Okay, angle equals half the arc. Then comes the floating angle. Man, these are horrible circles, but you get the point. So we'll say it's its arc plus its vertical angle's arc divided by 2. And then the last one is an outside angle, which is the one we just talked about. And this is anything outside. So it could be 2 secants, it could be a tangent and a secant, or it could be 2 tangents. And all of those are big minus little divided by 2. Yep.
I don't really understand the floating one.
So the floating one, I mean, you'll see in an example in just a second, but it's any one in which that vertex is inside the circle but not on the center. And it's going to make an X. So you do the arc it intercepts on the one side plus go across the X, the one its vertical angle intercepts, and divide by 2. But again, you'll see it in like numeric form in just a minute. Oh, sorry. Example 1 says UT, and that should be an is, not an us, is tangent to the circle. We want to find the measures of what's listed there. So arc WT is right here. Okay. Let's look at the circle that we've got, right? We said what's true about that exterior angle that's here.
That one and the bigger one.
Oh, you don't know. You can use that it's 90, sure, but that's, okay, let's talk about that. Because that is true. It's a good point, right? This is a 90 degrees because it's a tangent and a circle, right? And a tangent and a chord. So this would be 60. But what else is true about what we just learned about that exterior angle?
Bigger arc, that's 100.
Good. It would be big minus little divided by 2, right? So big is here, that's 100. Minus little, that's actually what we don't know. Divided by 2 is going to equal the angle outside, which is 30 degrees.
So 2, 100 minus x plus 6.
Good.
X equals 4.
So that gives me the measure of that arc. Then it says angle TVS, which is what is here, right? That's a floating angle. But we also have that linear pair situation going on. So let's look at it both ways, okay? Let's do the floating angle because that's what's new to us. That's a floating angle, which means I'm going to take and add the 100 because that's what it intercepts. Plus its vertical angle, which is here, intercepts 110. I'm going to divide by 2. So 210 divided by 2, which is 105. So this is not drawn to scale because those two things should overlap, okay? You should be able to get your linear pair from there, which is it's wrong, okay? I just threw numbers on a diagram. They should overlap. So 105 is the answer that we want. Again, it should have been linear pair with the other side, but
Can't RVS be a linear pair?
yeah. Technically, this should have worked to be a linear pair with this, but I literally just threw numbers on and then all of them made sense to overlap. Let's just practice the ones that we're trying to practice. So we were trying to find TVS because this is 105 and this is also 105. Now RVS.
You do linear pair there.
Good. So RVS would be here. Okay. Again, we're going to ignore this because technically it should be true, but it's not. These could be a linear pair. These could be a linear pair. Or there's one more arc missing that I could find, and I could also do the floating angle there. But this could be 75 because of the linear pair.
Wait, how would you do the floating angle?
So I would take 40. Well, I would have had to know this angle here. Yeah. You would have had to know one or the other with the linear pair. Okay, and then arc RS at the end. Now I've got this angle, right? We just said that this was 75. And I can say 75 equals 40 plus what we don't know divided by 2. Because 75 is one of those floating angles. So 150 equals 40 plus x, and x equals 110. Yep, you could also add them all and subtract them from 360. That's what you're saying? Yeah, so 110 plus 40 plus 100 and 360 minus 250 would be 110.
How did you get to 75?
So once we found one of the 105s, we did the 105 first, right? We did the 105 by adding the 2 and dividing by 2. If I add this and divide by 2, I get this angle or this angle. And then I use the linear pair. So the fact that these two add up to 180. Yeah, Brian.
Why couldn't you do the same for 105? Like if you got 60.
60 was wrong. That's what I'm saying. Like I threw this measurement on there, but technically it doesn't work with the other measurements.
Oh.
So I couldn't use that one. Yeah.
How do you solve for
RS, you could do two things. One is add the 3, nope, not that one. Add 110, 40, and 100 and subtract it from 360. Or RS would be the relationship with 75 and 40 would be that 75, because that's my floating angle, equals 40 plus what we don't know divided by 2. And we solve it that way. So you could do it either way. All right, example 2 says if the measure of arc AB is 105, so this whole arc here is 105, then angle D is what? Angle D is what kind of angle?
It would be
It's the outside one, right? So this is a big minus little divided by 2 equals angle D. Yes? But I have 2 unknowns, right? Can I fix that?
yes.
How?
Get a diameter. 180. That's
So that gets you that, yes. But what about this? How do I know what that is? So I could do 180 minus 105 and add it to the 180 I already got, or what? Could I get this whole thing? 360 minus 105. You could do either way, but the other one is one less step. This is 255. So now I get 255 minus 105 divided by 2 equals angle D. So I get 150. 150 divided by 2, or 75, equals angle D. So usually with an exterior angle, you need 2 of the 3 big, little, or exterior angle. The only exception is if we go back to the 2 tangents like the ice cream cone shape, you only need 1, because from that one you can do 360 minus it to get the other one. So if I was given that 255 first, right? Like if I still wanted to know this angle, but I had 255, I could do 255 from 160, get this is 105, and get to it the same way. So the only time you only need 1 measurement is on the tangents. Yep.
Is this just coincidence, or is 180 minus 105 75? Just in that.
Only if you had a diameter. You might not have the diameter.
But for this one, it would have worked, right?
Correct. Okay, last one. This says the measure of arc AB is what? So again, I want this one. I have this one and this one. Where's that angle located? Outside, which means big minus little divided by 2. So the x minus the 20 divided by 2 equals 10. Multiply 2 on both sides. Add the 20. And x is 40 degrees. Questions on anything we talked about today? So again, lots of angles stuff today. Tomorrow we're going to get back into segments, but for now, we're talking angles. We're good? Yep. Okay, I'm going to open your assignment.